This video is going to do a quick demo of the Amazon Athena service. Amazon Athena is based on Hadoop Hive, but it uses Amazon's, like, all the data storage. You simply just store all your data sets into Amazon's S3 storage service. So you can store data in CSV formats, JSON, ORC. You can use unstructured data where you use regular expressions to define the tables. So it uses SQL or a variant of SQL to define where the tables are and where the data is in an Amazon S3 bucket. It also supports partitioning, so you can segregate data sets by things like years or dates or groups or individuals, however it makes sense, so you can improve the performance of your queries so you're not scanning hundreds of terabytes of really giant data sets. It also supports compression, so you can take let's say if you were using CSV files that were 800 megabytes uncompressed, you can compress them using like bzip2 compression, and you're only storing like 170 megabytes instead of the 800. So additionally, you're only billed for processing 170 megabytes for the file as opposed to the full 700 megabyte file. So for this example, I used a NOAA vessel tracking data set. So let's take a look at that. This is the website for it. So it's got U.S. Coast Guard naval traffic data sets where it has vessels, GPS locations of the vessels, when it happened and when it was tracked. So this is the example data set. Let me close this so it's a little bit bigger. This is a sample of the data set, and for each year it has about 350, 360 gigabytes worth of uncompressed CSV data. So it's got the vessel type, the vessel name, their call signs, and latitude, longitude, and when it was happened. So I downloaded all these data sets from NOAA for 2018 and 2017. So I'll show you on my file system. Here is locally all the data sets that are compressed into bzip format, and each one's about 178 megabytes, and that's about one file for every day. So in the uncompressed version of that, the file is 746 megabytes, so pretty big difference. So we have our data sets, and then I've uploaded them to Amazon's S3. So here is my ISW logs, and I put this under AIS, and I have a folder for 2017 and a folder for 2018. Load it up, and there's all my bzip files. So for this entire year, compressed, it's 58 gigabytes worth of data for a year. So uncompressed, it would be somewhere around 350 gigabytes. So I'll start in the Amazon console. So service is called Athena. So I'm going to go through and I will do, first I'm going to delete this table. When you delete a table, you're only deleting the definition of the table. It doesn't actually delete the data that's stored in S3. These are not write databases. You can't write to them, you can only read. So I'm going to go through creating the table. And copy my query here that I have. I'm going to give the table a different name because I already have one with this name, and I'll call this one non-part for non-partitioned. So looking at the example data set, the CSV, so we have all the fields in a row, and our definition of the table follows the same. I have all the field names. Now I could have called these things differently, but I have one field for each one of the values in the CSV format, and I say the row format is delimited. Fields are delimited by a comma, which is a very easy data set. So, and then under location, it has the S3 location of where it's stored in Amazon's S3 service. Now, I don't need to define whether the data files are CSV files or compressed. It supports gzip, bzip, and a couple other compression formats, but I went with the highest compression one. So Athena will look for anything underneath this bucket key. This is the bucket key, this is the bucket. So even if there was like a million folders or files scattered around, 1,000 different places underneath this key, it would search for all of that based on this definition. And then also under table properties, I'm skipping the header, which is just the first line that has, your header line. So to find it, got it. I'm gonna run this query. The query ran successful. So here is my new table. And I can do like a preview of the table, which it'll scan like 10 lines off the first file. And you can confirm that there's my lat, there's my longitude, here's all my data fields, they all look good. Now, if I would have had like, let's say, if I would have counted this as an integer or something, I would have noticed a problem that it wouldn't be showing me the correct latitude and longitude. It would probably just say 34 or something like that. So this is where you would go and proof your data definition for your table. So I'm not going to go ahead and I ran some previous queries. So under the history tab, we can look at some different queries that I ran. So this is under, okay, non-part. So here's a query I ran. It shows you the SQL, and it shows you how long it took, 87 seconds to run, and data was scanned was 58 gigabytes. So we can go back and look, and it's 58.3 gigabytes in this bucket. So yeah, that makes sense. So if we click on it, 58. So any query that you run, it stores the output of the query. So you can look at it here, but really you just download the CSV file, because some of these are going to be very large return results. So out of this one query, I was looking for just this one ensign vessel name. It returned a 10 megabyte CSV file for the entire year. So just loading that up to show you. So here is our ensign CSV query output. It's got the date, lat, and longitude. Now this, you can do a lot of regular SQL. This supports joins. And save. So I'm going to go back and show you some more queries that I ran earlier today. So you can also support partitioning, which I did that based on, for this one I did it based off of the year. So I created, let's see, going down. Okay, yeah. So here's the same query, or the same table definition, but now I said partition by, and then I created this year field, and I said it's a string. After and then I defined it underneath this folder, so I didn't put it under this specific years. So then I did a alter table, and then I added a partition for the year, and then I put the actual year definition, and I added both of the years. So if I look under my queries, here's one where I did a vessel name, but I did it over 2 years, and you can see a total of 108 gigabytes of data were scanned. And in Amazon, I'm going to go up just to, there we go. Okay, so if I look at all my BZ2 files, I can see that it's 108.5 gigabytes. So there we go. So in this query, I scanned the entire data set of 108 gigs. It took 2 minutes and 54 seconds to run. And so I was billed for 108 gigabytes of data. So, but in reality, this is compressed data. So the actual data set is like 700 gigabytes of data, 750 gigabytes of data. Now, if I go under history, I did a query that shows the example of running a partition query where we specify the year. So let's say if I was just looking at 2008 data, I said year equals 2008, only 58 gigabytes of data was analyzed for this query, and it ran in 1 minute and 28 seconds. So you could even do it by year and month, and then it would be even much smaller. So you can work out your queries in a partition table with really small data sets, and then when you needed to do a really large run, you could then run it, once you've debugged your query, run it against the giant data set. So you could have data sets that grow into millions of different files and can grow into petabytes of data, because they're all stored in Amazon's S3 service. Some other examples that I wanted to show was we had, this is an example of running query against AWS access logs. And this has joins in it to other tables. This is kind of a complex query. I'm not going to go through all this, but basically it's going through a bunch of AWS access logs. So I have my, let's find the access logs up here, with logs, and okay, ALP logs. Here's the access logs. And then I'm joining it against some GeoIP databases, 2 different tables. So there's like 3 tables total in this. So this one took 2 minutes and 28 seconds to run. 23 gigabytes of data were analyzed for it. And basically what I was doing was trying to map up where the large amount of requests were coming from Amazon's access logs to the GeoIP database. So I got the client's IP. He made 581,000 requests from Ashburn, Virginia, which is just a big data center city there. Got a ton of requests, 240,000 requests in this time frame from Germany. So this is obviously some kind of attack on the site. But this is another example of data sets. That's my overview. I put several examples inside of this Confluence page that goes over different types of access logs, your own custom data sets, and as well as a regex example, and as well as some cost estimates. So, for example, a 10 terabyte data set, if we were scanning the entire data set, would be like, it costs $50 if it was the raw, and then under compressed version, it would cost only $16.50 to run a query against it. Whereas if it was partitioned by year, it would only cost $1.65 if it was compressed, and then if you did it by a month, it would do it for under $1. Their base cost is just $5 per terabytes of data scanned.